Good morning, class, and welcome to our first virtual lesson. Aren't you so excited? You get to stay at home and eat and, stay in your pajamas or whatever and still do school. I'm excited too, even though clearly I cannot do the same. That's fine. We are talking about simplifying square roots because that's where we left off last time we were here. We had Pi Day and we watched a movie for no apparent reason. And then we came back and we briefly squeezed in a lesson. So I wanted to redo it just in case some of you may be like, okay, I don't remember this. So here we go. Do you remember the product property of square roots means that the square root of AB is the same as square root of A times the square root of B? Obviously, it's easier to see that in numbers. So the square root of 18 is the same as square root of 9 times the square root of 2. And why do you think we use 9? Because we know the square root of 9 already is 3 times the square root of 2. So we can simplify square root of 9 as 3 and leave square root of 2 because we don't want a crazy decimal. We want to keep it in number form and square root form. So another example, the square root of 12 is the same as 4 and 3, and the square root of 4 is 2, and so that's all we can do to simplify it. So with smaller numbers like this, you can just use numbers you already know the square roots for, and then it'll be easier. But when we get to bigger numbers, we have to do some more serious factoring, which isn't too big of a deal, but I think the example in your book is 600. So to factor 600, I have here 60 times 10, and then that's 3 times 20, 5 times 4, 2 times 2, and in your answer right now, you can answer out loud, why do we circle the factors? Why do we circle them? They're just like, we could just look at them. Well, thanks for answering correctly. So they stick out, the ones that you need, the prime factors. We don't need 60, we don't need 20, we don't need 4 because they're not prime. And then the square root of 10 factors to 5 and 2. So the square root of 600 is the same as saying the square root of, well, there's three 2's, 1 3, and 1 5. I think I'm correct there. Yes, I want to be very sure. No, 2 5's. I'm sorry. So if we're looking for pairs, we have a pair of 2's and a pair of 5's. Remember, 2 become 1. I made this weird joke about marriage last time I tried to teach it. Half of you heard of me, half of you didn't. So now you have to hear me. Gotcha. So the 2 become 1 on the outside. So 2 2's become 1 2. 2 5's become 1 5, and then we're left with just the 2 and 3 under the radical. So just multiply, and we end up with 10 times the square root of 6. That's simplified. You're not going to, well, I guess some of your calculators might do it in this form if you just, punch it in your calculator, but I'm begging you, please just learn how to do it this way without the calculator in front of you, without, using those shortcuts. I know I can't really be on top of you when you're at home, but you need to understand this stuff without just relying on a calculator as well. Moving on. Here we go to example 1 and example 2, which you may remember because we already did it in class. So number A, letter A, don't at me. The square root of 216. So we use 2 times 108, and then we have 9 times 12. 3 times 3, 4 times 3, 2 and 2. Okay, circle all the prime numbers. So the square root of 216 is really the square root of 222,333. And it's important that you know that these are multiplied. This is not just 222,333 because then that's 222,333. Make sure you're putting your dots in the middle so you know, yes, these are all multiplied. And then look for pairs. And what pairs do we have? Thank you. We do have a pair of 2's and we have a pair of 3's. So those 2 become 1. And then we are left with 6 times the square root of 6. Hopefully you realize I multiplied. That's all I did. Okay, nothing crazy. So here's our first example actually of when we factor and we take out the pairs and we're left with 6 times the square root of 6. I don't even have to wait for you to write that down because you can just pause the video if you need to. We also have letter B is the square root of 210. You do not need a calculator to figure this out. 7 times 3 is 21, so 7 times 30 is 210. Which brings us to 5 and 6, which brings us to 2 and 3. Do you see any pairs in this one? No, we don't. So we just leave it as is. No pairs, no simplification. Bye. We're done with this. It's just the square root of 210. So there we go. Those are two bigger problems, bigger numbers where we just have to factor it down and see what we have. Moving on. There's something about Alfred wants to take a shortcut and they have a beautiful right triangle. Point A and point B, if they're backwards, please give me a break. Point A and point B, he doesn't want to go 200 yards. I think it was yards. That's like 2 football fields, you guys. 200 yards. That's a long way to walk. And he's like, I'm taking a shortcut because you know Alfred, he's always taking shortcuts. So just looking at this beautiful right triangle, we don't know the hypotenuse. So what pops in your head automatically that we can use to find that hypotenuse? Yes? The Pythagorean Theorem. Thank you. I'm pretending there's people here because I'm maybe going crazy. So he does a squared plus b squared equals c squared because we all know, duh, that's the Pythagorean Theorem. Plug in your a, plug in your b, and we're going to find our c. 100 squared, since there's 2 zeros, we now have 4 zeros. Same thing here. 4 zeros. So do a little bit of addition. And do we want c squared? No, I don't want c squared. I just want c. How do we get rid of the squared? Ask yourself, do you remember what the opposite of squared is? Yes, it is the square root. You're so smart today. Oh my goodness. Sorry, I'm weird. Okay, so c is the square root of 20,000. So instead of saying, okay, put it on my calculator real quick, we just learned how to simplify this by using our factoring. So I'm coming over to here, so I'm running out of space, to factor 20,000. Okay, this is 10,000 times 2. And you're going to see very quickly why I use these two numbers. Because this 10,000 is the same as 100 times 100. And that pattern is something we should have seen over here, right? We should have already realized, oh yeah, it's 100 times 100. Well, instead of going all the way down, I already have a pair right here, right? So instead of going down and doing, 10 times 10, 5 times 2, 5 times 2, which you can do, I wouldn't recommend, but you can if you want, these two become 1 on the outside. And it makes it very simple. So 100 times the square root of 2. And I think in your book there's some like approximations. I didn't write them on my notes, but the approximations of the square root of 2, the approximations of the square root of 5, there's a couple on there. I just want you to look at those so you can see. But this is our last example. So if you're simplifying square roots, look for pairs when you factor, bring them on the outside, they become 1. And that's basically it. So thanks for joining me. I will see you tomorrow, same time, same place, or a different time, different place, up to you.